Good day, welcome to another video where we'll be studying a new chapter on number patterns, in this case finite arithmetic series. So remember, in grade 11, right, you'd have an arithmetic sequence which, for example, would go by -8, -2, 4 and 10, of which it therefore have common difference between consecutive terms, right? And then from that we know that the common difference, we calculate it as t2 minus t1, which will be, for example, -2 minus -8, which will give us 6, and we'd use that to solve the general formula, of which here a is our first term. We know a is -8 plus in bracket n minus 1. The difference is 6, right? Therefore we'd have -8 plus 6n minus 6, and then from that you'd have 6n minus 14 as your general formula. So okay, what I'm bringing to you guys with finite arithmetic series, the question now is, what if actually maybe some of you might have wondered, what if we're to add these consecutive terms? What if we're to add them together? Adding them together means something like -8 plus in bracket -2 plus 4 and then plus 10, right? What if we're to add these terms? Obviously in this case we'd get 4, right? Adding them manually. This is our t1, t2, t3 and then t4, right? What if we were to add them manually? And then now let's maybe say we wanted to add these terms all the way to t100, all the way to t100, of which that for you will be 6 in bracket 100 minus 14, right? You can calculate that. Okay, that will be the term right here. So what if we were to add many terms such that adding them manually consumes time, and we want to add them in a simple way? So that is what this video will mainly be focusing on. So here we know that our first term, right, our first term is a is our first term, and then we know that d is the common difference, right? And then we know that tn is the general formula, and then I'm now introducing a new term to you guys, which is L. So L is what we're gonna refer to as the last term of an arithmetic sequence. So okay, let's continue. So think about it. We must come with strategic ways of expressing these many terms without having to represent all the way from t1 all the way to t100. So one of the best ways of doing that is to use sigma notation, of which this is stands for sigma, and then in this case, of which again we added -8, -2, 4 and 10. So there we'd basically say n is equals to 1 and then n is equals to 4, basically meaning that we are summing numbers. We are summing terms from t1, from the first term here. We are summing from the first term all the way to the fourth term. But then what formula or kind of numbers are we summing? That is where we have tn here. So what is this tn in our case? We know that tn is equals to 6n minus 14, right? Which is equals to -8 plus in bracket -2 plus 4 plus 10, which gives us 4, right? So how do you interpret this in words? This basically, I'm just gonna use a red pen to show you. So this is actually the sum of this general formula from the first term all the way to the fourth term is these numbers here, right, which gives us 4. So that is how you can interpret it in words. And then another way of actually representing this is basically calling this S4. So S4 basically is -8 plus -2 plus 4 plus 10. And then the S4 basically is the sum of the first 4 terms of this sequence, right? Of which now, what if now we wanted a general way of dealing with many numbers, of which it can be 1000 terms. So we therefore come with Sn. So Sn is sum of n terms of an arithmetic sequence. The n can be 2, the n can be 1, the n can be 1000, million, any terms, right? Of which, let's go back to S4. S4 basically is a plus a plus d plus a plus 2d plus a plus 3d. What do I mean by that? This is the first term, this is the second term. We know second term, we find it by the first term and adding the common difference, right? Third term, we say first term plus twice the common difference. And then the fourth term, same thing. Of which here we know we have -8, we have -2, we have 4, we have 10. You add this together, you get 4, right? Okay. So now let me write this. Let me take this down again. In a general sense, right? What we therefore write is maybe let's say we want 100 terms. We'd say a plus d, right? T1 and then T2, right? Plus a plus 2d plus, we wouldn't, there's no need to show all the terms. This shows that these terms that are in between, but we're not showing them. And then think about it, right? If ever we have the last term here, the last term, I'm writing the last term at the end, plus the term before the last term will basically be what? It will be L minus D. Because for us to find L, we must say L plus D, right? So, and then the term here, the second term, the third last term will be what? L minus 2D. So this here is basically the same as Tn minus 2. This is the same as Tn minus 1. This is basically Tn. Tn being our last term. If n is 100, therefore that will be 100. And then the other one will be 100 minus 1, T99, right? So let's write this in reverse. Writing this in reverse, we're gonna get L plus L minus D. Remember, L is the last term, right, as I defined it above. And then here we're gonna have L minus 2D and then plus, we don't show, and then let's write these values here. We're going opposite, right, as I said. Then this will be a plus 2d plus a plus d and then plus a, right? So think about it, okay, before that, let me just write this. Let's add this together. This will be a plus l, right? When you add the two together, let's add when we add the two equations together, right, we get a plus l, and then adding these two together, you also get a plus l since the d's cancel, and then here the two d's cancel, you get a plus l plus, and then here the d's cancel, you get a plus l again, plus a plus l, and then the last one as well, you get a plus l. And yeah, okay, so now think about it, right? Let's say maybe you had x plus x plus x plus x, right? So basically you can represent this as what? As 4x, right? But then you know that basically 4, you can call it n, so it basically becomes nx, right? Such that, let's say it was 100, therefore this n will stand for 100, né? So in this case we have Sn. So let's let our n stand for whichever many number of times these ones are, that this n will stand for that. So we therefore get n a plus l, right? And then here, sorry, this is actually 2, since we're adding Sn plus Sn. I was supposed to have written this right here, right? So apologies on that. This right here is 2n, because when you say Sn plus Sn, we get 2n, right? And then also it triples down, we also get 2Sn here as well. So from that, we therefore divide by 2 and then divide by 2, right? And therefore you get Sn being equals to n over 2, and then here this will be a plus l, right? Of which from these you get n over 2 and then a plus, what is l? We know that l is Tn, right? L is equals to Tn, but what is Tn? Tn is a plus n minus 1 d, right? Therefore this will be equal to a, we can put it in a bracket, a plus n minus 1 d, right? And then from these we therefore get n over 2. When you add the a's together, opening the bracket, you get 2a plus in bracket n minus 1 d, right? So this right here is our general formula basically for summing a certain number of terms in an arithmetic sequence. So in this case, having to sum the first 4 terms as we had previously, you'd say S4, which is equals to n 4 over 2, and then 2, our a, we know a, our first term was negative 8, right? And then plus here you'd say 4 minus 1, and then the difference was what? Common difference was 6, and then you'd calculate here, of which obviously you are supposed to get 4. Yeah, but you may calculate for me and tell me what you get. And then here we have S4 as well, of which, remember, upon proving that we actually in this step here, basically what we had was that Sn is equals to n over 2 a plus l, right? So there's that, so you may also substitute for me. So basically an is equals to n over 2 a plus l, and then this S4 is equals to 4 over 2, and then what is a? We know our first term was negative 8 plus l. The last term was 10, right? Yeah. And then so please calculate this for me and tell me if you get the very same answer as here. And then yeah, that is it, guys. So in case you wanted to calculate as 100, as I've been making an example, you'd say 100 over 2, and then okay, going back to the formula, we'd have 2 negative 8 again plus in bracket 100 minus 1, and then the difference is 6, and then you therefore find the answer. Thank you for watching the video till the end. Kindly stay tuned to watch more interesting maths videos. Thank you. Please like, share and comment and subscribe.